General relativity, step by step. I've got the geodesic equations here for slowly moving objects in a stationary, weak gravitational field. And last time I showed that time and t and tau were related linearly by considering the mu equals 0 component. Now I'm going to consider mu equals 1, 2 and 3 and see what happens. So I'm just going to substitute it into this equation here, and we've got d2xi. You'll remember index I runs over 1, 2, 3 by d tau squared equals a half, just copying from here, eta mu lambda di h 0, 0 by di x lambda c squared dt by d tau squared. Well, the first thing I can do is replace my d by d tau with d by dt, and I can just say d2xi by dt squared equals a half eta mu lambda di h 0, 0 by di x lambda times c squared. I think I've got a minus sign missing here. And so I'll just write that a bit more neatly. That's eta. And so because my eta is minus 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, I can replace that with minus a half c squared just times the gradient of h 0, 0. So the acceleration of the 3 acceleration is minus c squared over 2 times the gradient of h 0, 0. And of course that's minus c squared over 2 times the gradient of g 0, 0. And if I take g 0, 0 to equal minus 1 minus, it's easy, there's lots of minus signs here and it's easy to get confused. I'm not entirely convinced I've got all my signs correct in this screencast. 2 phi over c squared, if I just formally make that identification, where phi equals the gravitational potential in joules per kilogram, I guess it is. Then we recover, just in one fell swoop, we recover minus c squared over 2 times the gradient of g 0, 0. We recover the whole of Newtonian mechanics, the whole of orbital mechanics. You've got all of Saturn's rings, all of the resonances between Jupiter and the Trojans, all this rich variety of dynamical behaviour in the solar system. It all boils down to this single term here. And you might argue that we haven't made any progress because we've replaced Newtonian dynamics with something that's the same. It gives the same predictions. Well, yes and no. We've replaced an arbitrary force law, an arbitrary mechanical force law, with a geometrical construct. We now consider the planets to move on straight lines, or at least geodesics, in a warped space. This is a much more primitive, much more pleasing, much more mathematically amenable system to deal with. And of course, once we've got the idea that we can recover Newtonian dynamics to first order, we can try to solve the equations a little bit more accurately. So it's quite an astonishing achievement, really. I just want to make the observation that phi over c squared, which is dimensionless, is of order 10 to the minus 6 in the solar system. Oh, it's negative, isn't it? Minus 10 to the minus 6 in the solar system. Obviously very, very small. And even if you deal with white dwarfs, it's 10 to the minus 3 or something for a white dwarf, which justifies our linear approximation. So we've got this beautiful, beautiful system here, and it reduces down to Newtonian dynamics. I think it's absolutely incredible. I'm going to stop there. Stop.